right, as we get started today, go ahead and take out your practice exercise book. Let's turn to practice exercise 65. Practice exercise 65, and working with percents here. And remember, a percent is simply a decimal, right? But a decimal is simply a fraction. So in finding percentages, you simply make a fraction, but then you do what the fraction bar tells you to do. A fraction bar class literally means divide. So if I said that 2 out of 5 people got sick yesterday in this class, which we have more than 5, but anyway, just making up the number 2 out of 5, you'd make that fraction 2/5 into a division problem class. 2 divided by 5, that would give you a decimal. Then you'd move the decimal place twice to get a percent. So 2 divided by 5 would be 0.4. Move it twice gives you 4D percent. Make sense? That's what you're going to do here on exercise 65, but there's a little bit of a extra thinking level on this. Exercise 65. Go ahead and get started. Yes, sir.
What is a perfect square?
Oh, no. Well,
I probably know it. I'm just
like 1 would be like 1 squared. So that's perfect square. 225 is 15 squared, so 225 would be a perfect square.
Okay.
Yeah. 49 would be a perfect square. Excellent. Working on exercise 65. Just another minute to be finishing up. Let's go ahead and take a look at these together, so pencils down. These types of questions that involve a little bit deeper level of thinking are the kind of things you'll see on your senior year college board testing, where it's not just do this, it's think through what you've learned, then do what you know. You know how to make percents from fractions. I did a quick review just to refresh your memory, but you learned that. But you have to do a little thinking first. So it says, what percent of the first 15 whole numbers have exactly 4 distinct whole number divisors? Well, you never learned that. You have to figure that out, right? So curious to see how we did on this first question. Chris was first. Chris, what did you get?
20%.
It is not 20%. You were second?
27.
It is not 27%.
33.3 repeating percent?
Good, 33.3 repeating percent. Let's think about 1. Well, the only divisor of 1 class is 1. The only divisors of 2 are 1 and 2. That makes it prime when it only has 2 divisors. 3, of course, 1 and 3. 4, 1, 2, and 4. I mean, 2, you can't say 2 times 2 because that's not distinct, right? So that doesn't count yet. 5, of course, is prime, so just 1 and 5. 6?
1, 3, 4, or 1, 2, 3, 6.
1, 2, 3, 6. So there's one of them. What about 7?
7, 1, 7.
Now, what about 8?
4, 2, 1, 8.
Ah, 1, 2, 4, 8. What about 9?
1, 3, 1.
1, 3, 9, right? If you said 1, 3, 3, 9, that's still not 4 distinct ones, though, right? What about 10?
5, 2, 1, 10.
1, 2, 5, 10. 11 is prime, so just 1 and 11. 12?
Wait, why are we going to...
It says the first 15 whole numbers.
15.
So for 12, it's 1, 2, 3, 4, 6, 12. Yeah, that's too many. That's not 4, that's 6 of them. 13, of course, is prime, so 1 and 13. 14. 1, 2, 4, 7. What about 15?
5, 3, 15, 1.
All right, 1, 3, 5, and 15. So that gives us 5 of the first 15, and we divide it, comes out to 1/3, which is 0.3 repeating, which is 33 1/3%, or as Jamie said, 33.3 repeating percent. Next one then, Jamie, we'll stay with you. I'm going to dig at the 33 1/3% like Jamie. All right, good job, Genesis. All right, moving on to the next one. It says, what percent of the first 10 whole numbers are prime? This one a little bit more straightforward, Jamie.
40%?
40%. Of course, we'd already said 2, 3, 5, and 7 are your prime numbers. That's 4 out of 10, which is 40%. And the last one, what percent of the first 10 whole numbers are perfect squares, Jamie?
30%?
30%. Of course, 1, 4, and 9 are those perfect squares. The last two significantly easier than the first one. How many got the last 2 correct at least? All right, questions on exercise 65. All right, let me go and collect them from you if you would. And let's go ahead and practice construction 13 one more time. Let's go and practice construction 13 one more time. Of course, you practiced it once for your homework. Let's practice it again, just to make sure we're good to go as we review over this. If you want to use the back side of your construction quiz from yesterday, you're welcome to do so. As opposed to wasting space on a page, some blank paper you've already got readily available. So compass and straight edge out. As a strategy tip, you want to give yourself a pretty good sized triangle to work with. Don't make it real little, or you're going to have a really hard time putting a circle inside your triangle. So give yourself a good sized triangle, maybe on the back of that construction quiz. Or any other loose paper would be fine as well.
Do you care if it's obtuse?
No, not real picky there. As we showed yesterday, regardless of the size or shape of the triangle, an inscribed circle, of course, has to be inside. So, whereas with the, and the in the center then must also be inside, as opposed to, remember, the circumcenter, when you're circumscribing a circle, could lie outside or even on the triangle. The in-center will always be inside. What do we do if we want to inscribe a circle? If we want to find that in-center, Kendall?
Do the angle.
Good, we're going to bisect the angles. And technically, Kendall, you have to bisect how many? Two. But it wouldn't be a bad idea to bisect all three. Would not be a bad idea at all. So I'm going to go ahead and see if I can bisect all three. If you're a little slower at it, that's okay. Just bisect two of the angles if that's the case. But bisecting all three gives you a better chance to be accurate. Bisect those three angles in the hopes. Ooh, this might be the best I've ever done. I actually got all three of mine to perfectly intersect like they're supposed to. It's hard, especially on the chalkboard, because the thickness of the chalk kind of throws things off. How many got one exact point that all three intersected? Okay, if you only did two, obviously they have to intersect.
I have a question.
Yeah.
If we haven't started the third,
You don't have to do the third, no. Now, Ethan, since you weren't here yesterday, we knew that the in-center, which is the center of an inscribed circle, would have to be the angle bisectors, right? And Ethan, it would make sense then, right, that once you find the in-center, looking up here,
all right, I'm almost done.
it's okay. Once you find the in-center, you put the point of the compass here and you make your circle. The question is, how far do you open the circle? Open the compass. When circumscribing, you would measure to a vertex, right? But when you're inscribing, how do you know how large to open it? What do we have to do next? Audrey? We need the distance, Ethan, from this in-center to one of the sides. It should be the same distance all the way around, right? We've proven that already. But to construct the distance, that means we need a perpendicular. So the next step after we've bisected all these angles is to do construction 5. Open that compass more than the distance to the line. Make an arc that cuts through twice. Make intersecting arcs. And connect the dots.
Almost had him.
Okay?
Almost had him.
And once you've got the distance, class, you simply measure it and
Draw a circle.
draw the circle. And a rarity has happened. It actually worked perfectly. I usually have some degree of error when I'm doing here on paper with pencil and compass where the compass can't slide. I'm usually a lot better with the chalkboard. It's pretty rare that I actually hit it perfectly. So, not a perpendicular bisector, Jamie. The perpendicular. So that's where you're going to want to. Let's go to a different side. Oh, I see what happened. They all missed each other pretty badly, didn't they?
Mm-hmm.
You know where I think the problem was? I think it was this angle. Looks a little bit off. So remember, we don't need a full, like, fishy thing. We just need a little arc out here. And you can see how far off it is, can't you? So it actually would have gone more like up here, so maybe somewhere up here. But again, remember, that's where you're going to want to make that arc through. A couple of arcs here, and then connect that to this. That'll get you your perpendicular distance. And then let's just assume it's right about here. Then the circle will come closer to actually hitting all three sides. All right, we'll practice it again later on. Hey, really good, Quinn. I wouldn't take any points off because I can't actually see even space. Like, it went just a nudge outside, but not so far outside that there's not even really space between the two marks. Kind of like, you know, in football, they're like, can we see any green between his foot and the white sideline? Yes, I can see green. He's clearly not out of bounds. Okay, as long as I can't see green, or as long as I can't see green, yeah, between the two. Yeah, I just missed that little bit there. That's all good. Again, it's really hard to hit it. So, again, on construction, hey, I think you did, though. Good job. Good. Very nice, Genesis. Good. Just the tiniest nudge out there. Good. And then for your first time, not shabby at all, Ethan. All right. We're going to move on. What?
The name of the construction?
This is inscribing a circle
And then
within a
I'll
triangle.
get
Get the steps later. Yep. All right. Go ahead and take out a new sheet of paper to go in your notebook. Go and take out a new sheet of paper that will go in the notebook, preferably again, reinforced edges would be good. And let's move on to our next construction, construction 14. Now, construction 14 is constructing a tangent or tangent. So we're going to break it into two different constructions. We're going to have construction 14A and construction 14B. So at the top of this sheet of paper, construction 14A. Construction 14A is to construct a tangent to a circle at a point on the circle. Construct a tangent to a circle at a point on the circle. I'm not OCD or anything. Construct a tangent to a circle at a point on the circle. Once you've done that, if you would, go ahead and draw a circle. It doesn't have to be incredibly large, though, don't make it too small either. When you've done it, if you would, make sure you mark where the center of your circle was. It should be easy enough to find considering you have an indentation in your paper. Hopefully not a full hole, but an indentation at least. And then if you would, pick some point, any point. Tell you what, give me a clock position here. Quentin? 8 o'clock? All right, so let's come over to 8 o'clock and let's put our point there. So we're going to construct a tangent to our circle at 8 o'clock. Before we go over the steps here, let's just think tangent. What do we know about a tangent, class?
So one point on the outside of the circle.
Okay, only touches 1 point, but what's kind of the Klein response to tangent?
Perpendicular.
Perpendicular, right? Perpendicular to what?
A radius or diameter.
Radius or diameter. Well, so what you're saying is, if I had a radius or diameter, and I put a perpendicular, it would be a tangent?
Yes.
Yeah. So it makes sense then that based on how we know this should work, we just do what it says. Step number 1, going down to the bottom of your paper. Step number 1, draw a radius extended through the point. We're going to take a little bit of a liberty here and extend our radius because it's going to make the construction easier and I'm lazy. So draw a radius extended through the point. Draw a radius extended through the point. The reason I extend it through is because to construct a perpendicular, I'd like to be able to remember make marks on either side. Well, I need to have another side to go off of. So we extend the radius first. Step number 2, construct the perpendicular at the point. Construct the perpendicular at the point. And then in parentheses, construction 4. Construct the perpendicular at the point. And then in parentheses, construction 4. So remember for construction 4, you open your compass smaller than the short piece, which in my case, the shorter piece was outside. For you, the shorter piece may be inside. It really doesn't matter. Open your compass less than the short side. Make a little mark on either side. Then remember, you're going to have to open the compass wider. The more, the better. Make an arc above. Go to the other point, make another arc above. Get a little X outside the circle. And then simply connect the dots. Little arc on one side, little arc on the other side. Open it more. Make an X. And when you connect the dots, you've got your tangent.
You say that again. Sorry.
Okay, remember construction 4, which is in your notebook. But you open the compass up less than the short side. Make a little mark. Make a little mark. Then open it wider. Go to each of the intersections to make an X or intersecting arcs above the line. And again, it's exactly the way you would have thought it should be, right? You know tangent means perpendicular. You assume, yes, I just need a perpendicular here. And so you put one. And boom, there's your tangent. Now, you might be thinking, well, I feel like this line touched the circle more often. Well, if it were infinitely thin, and the circle's arc was infinitely thin, they would only touch once, right? It's because there's some thickness to your lead. Certainly on the chalkboard, there's some thickness to that chalk. But otherwise, it would have to be perfectly tangent. Questions? Turn the paper over. Draw another circle. And this time we will let Chris pick our clock position.
2 o'clock.
I'm sorry?
2 o'clock.
2 o'clock. Surprised you didn't say 3. 3 o'clock's a good time, isn't it?
I'd rather lunchtime.
Ah, okay, 11:45. Just kidding. We're not gonna do
I
that.
should do something specific, like 1:32 with 30 seconds left.
All right, so see, there'd be 1, there'd be 32, and there'd be 30 seconds. So right there.
And 30 milliseconds left.
Anyway, so put your point right around the 2 o'clock spot. First thing we need to do, class, if we want to put a tangent at that point,
Extend your radius past.
good, radius extended. How much do you need to extend? However much you plan to open the compass. I would rather not open my compass a teeny-weeny bit. I'd rather be able to open my compass comfortably. So then, make sure you extend it far enough that the radius, you can draw your line comfortably. Then we need to make little arcs on either side. After I've made those little arcs,
You still with me?
anybody? Extend the compass. Once you've made those little arcs, remember, you've got to open the compass more. Go to each of those intersections and make intersecting arcs. Again, it's just construction 4. We know how to do that one. If not, you can go back in your notebook, look it up. And when you connect the dots, you'll have a tangent. I should say the tangent, right? Because there's only one tangent you can put at that point. What? Right. As many points as you put, you could make that many tangents, I suppose. I mean, that's one way. If you wanted to start with a circle and circumscribe a polygon about it, you could just pick another point, draw that tangent till it hits it, pick another point, draw another tangent till it hits that, and you just keep making more and more tangents. Now, the one thing, before I take your question, I told you make sure you mark the center. What if y'all really tick me off before the next construction quiz?
Possible.
And I don't give you the center? Just because y'all made me mad and I win every time. So what would you do if I didn't give you the center before, other than cry? I mean, that's not really a viable option here. Chris?
Well, you'd have measure the maximum length of the circle.
How would you do that?
We'll pick a point and just go and make a straight line across.
So pick a random point, just make a straight line across, like that?
No, opposite.
That is opposite. Without knowing where the center is, how do you, you might look at this and say, oh, that's opposite. That's a good diameter. No, it's not. It missed. But you don't know where the center is. On the bottom of your paper, draw another circle. On the bottom of your paper, draw another circle.
I don't have any room.
It's okay. Just don't make it, you don't have to make it a huge circle necessarily. Maybe, open your compass maybe about an inch or so. But don't mark the center point. How can we locate, I've mentioned it before in this class, how could we locate the center of a circle if you didn't know where it was?
Perpendicular.
You're on the right track.
Bisector.
Perpendicular bisector of what?
The tangent? No.
An arc?
A chord.
A chord. But not one chord. Draw any chord. Doesn't really matter where you draw it or how you draw it. Just draw any chord. And go ahead and draw the perpendicular bisector. So remember that, open the compass more than half, make an arc. Make an arc. Make an arc. Make an arc. Because remember, the perpendicular bisector of any chord passes through the center of the circle. So in drawing this perpendicular bisector, you know the center of the circle is somewhere along that line. But not just somewhere. Where exactly must the perpendicular bisector, where must the center be?
The midpoint.
The midpoint of this line. So where's the center? What would I have to do to find it?
Find the midpoint.
How do I do that? Okay, you could actually. You could draw, and that's actually what I told you once before, is draw another chord, do another perpendicular bisector, or, without even drawing another chord, perpendicularly bisect this diameter. And the midpoint would be where the perpendicular bisector goes to. So go ahead and perpendicularly bisect your diameter now. Didn't go long enough. Perpendicularly bisect your diameter. It would also work to draw any other chord and perpendicularly bisect that. And there's the center of the circle. So if I wanted a tangent at this point, for instance, but I didn't have the center of the circle, I could perpendicular bisector any chord, perpendicularly bisect that diameter, or some other chord. Now, I can go right through those steps again. Radius extended. Oops, that's terrible. Radius extended. Little arcs on one side, arcs on the other, and there's my tangent when I can screw that down. So anyway, questions on that? Just wanted to remind you, you can always find the center of a circle, even if I'm in a sour mood and don't give it to you. Questions on construction 14A though. Hey, just do what you're told, and I'll be nice and give you the center. All right, how about that? Construction 14B, new sheet of paper. Construction 14B. 14A, I give you a point on the circle, and I want the tangent that can be drawn at that one point. Construction 14B is to construct two tangents to a circle. Construct two tangents to a circle from a point. I'm going to be really lazy here. Construct two tangents to a circle from a point outside the circle. Construct two tangents to a circle from a point outside the circle.
I had a question.
Yes, sir, your question.
So if you had extended the radius all the way out,
Mm-hmm.
and then you had that point,
Mm-hmm.
and you made the other tangent, wouldn't they be parallel?
Oh, I see. If you made them at the ends of a diameter, yes. But if you just picked some other point that wasn't on the opposite
Like
side.
You extended the radius, you extended that radius, and you extended this one.
Right, and you put another perpendicular, yes, they'd have to be parallel tangents because they'd be at the ends of a diameter. Good question. All right, so what I need you to do now is draw a circle. Don't make it too big. Okay, so maybe an inch or less as you open the compass. Make a circle. Don't make it too big. Again, mark the center, though, as we already just discussed, you could find the center even if I didn't give it to you, but go ahead and mark your center. And then let's pick a point, come out here somewhere, and pick a point. Now, we have proven in the past that from any point outside a circle, two tangents may be drawn, and those two tangents must be equal to each other. I'm actually going to go through the proof first, and then show why it must work. So normally we talk through the proof as far as determining the steps. This one's not quite as evident, so I'm going to go through the steps first, and then have you, we'll go ahead and talk through the proof. Step number one is to join the point to the center. Join the point to the center. So draw a line, you could say, might be another way of putting it. Draw a line from the given point to the center of the circle. Join the point to the center. Draw a line from the point to the center of the circle. Now, of course, if we were to put a perpendicular right here, that would be a tangent at that point, but it wouldn't be two tangents from that point. The next thing we're going to need is we need to know the midpoint. I think it's right about here, but I can't think, I have to know. Step number 2 is to locate the midpoint of this line. Locate the midpoint of this line. I asked it a moment ago, how can I find a midpoint? Perpendicular bisector. So in parentheses, put construction 1, C-1. Locate the midpoint of this line, C-1. So remember construction 1, open the compass more than half, arc above, arc below. Go to the other end. Arc above, arc below. And connect the dots. Obviously, this is not tangent. It's not supposed to be. I went and drew the line dotted. You don't have to. I did that just to show. I really don't care about this line at all. The only part of the line I care about is right here, because that's the midpoint. The whole point of that line was really just for the sake of getting a midpoint. Step number 3 is kind of involved. Measure from the midpoint to the center, comma. Measure from the midpoint to the center, comma. Measure from the midpoint to the center, comma. And draw, excuse me, I didn't need a comma, wrong construction. I remember 1 and a 3 part, just and. Measure from the midpoint to the center and draw an arc through the circle twice. Measure from the midpoint to the center and draw an arc through the circle twice. Measure from the midpoint to the center and draw an arc through the circle twice. Measure midpoint to center, make an arc through the circle twice. A point up here where it crosses, an intersection down there. In parentheses, once you've done that, go and write this down. These are the points of tangency. These are the points of tangency.
Oh, there was.
Well, if I know the points of tangency, and I know the external point from which the tangents should come, what do you suppose my last step will be, class? Connect the dots. Cool. Connect the dots. Remember, from the given point to the points of tangency. I've seen students go to the midpoint. Okay, we don't want the midpoint. We're supposed to be coming from this given point. This construction has been dubbed the Death Star construction.
I like it.
If it were a point down below, it's been called the ice cream construction. If it's a point above, the party hat construction. However you want to think of it. I like Death Star personally.
I like the dunce cap.
You like the dunce cap? All right.
That's
I said party hat, but inwardly I was thinking dunce cap, but I was like, yeah, it sounds more
Were you
correct to
actually?
say party hat, yeah. So
Great minds think alike.
No.
and so do ours. But anyway, there we go. Now here's the question. How does this work? Because none of this was intuitive, right? How does this work? Well, imagine if instead of drawing just this arc, I've already measured here, what if I'd drawn the full circle? I'm lazy, so I didn't, but what if? Well, what is this line with respect to the entire circle I could have drawn. A
Diameter.
diameter, which means that this would be a
Semicircle.
semicircle. And if I had drawn this radius, I would have had an angle inscribed in the semicircle. And any angle inscribed in a semicircle is a
Right angle.
right angle. And so if I had drawn this line, I would have had a right angle to a radius, or a perpendicular to a radius, or a
Right angle.
tangent. So that's why it works. Again, without the whole circle present, it's a little less obvious. Without drawing the radii, it's a little less obvious, but that's the idea. You draw the what is going to be a diameter, you find the midpoint so that you're finding essentially the center of the circle, and since I'm lazy, I don't draw the whole circle, I just measure and draw just enough of the circle to get my 2 points of tangency and draw the lines. Make sense? Questions on this? Turn the paper over, draw another circle, and this time let's do, in Chris's honor, a party hat.
Come on.
This time though, actually, this isn't going to come out of party hat, because we're going to pick a point that's pretty close to the circle. Not too close, but a point that's fairly close. Last time we were kind of far away. Pick a point that's a little closer. This is going to come out more like a safari hat, I guess. So mark the center of your circle, and let's pick a point above the circle that's kind of close. Step number 1, class,
Draw a line
from
from point to center.
point to center. I say point to center, Ethan's like, right there, I see it. No, not that kind of point. Like, anyway.
Sloth from the goons.
Poor Ethan. All right.
You have to bully me like that.
I know.
Why you bullying me?
If you're not picked on, you're not loved. That's what
That's
that
not
is.
sorry.
All right. Now what?
Locate midpoint of line.
Find the midpoint. Draw that perpendicular bisector. In other words, the center of the second circle that we aren't actually going to draw.
R.
Again, this midpoint is the center of a second circle. We're too lazy to actually draw it, but whatever. Again, I really don't care anything about this line. I really only care about literally that point, that midpoint. Once I've got the midpoint, measure from midpoint to center. Not quite. And make, now technically you don't even have to draw the one big sweeping arc like this. You could just make a little arc over here, a little arc over there. But I don't see that there's a problem drawing just one sweeping arc. The main thing is you're trying to find these 2 points of tangency, and then we simply connect the dots. When you connect, by the way, don't stop at the point. Go ahead and go on through. Connect on through the point a little bit there. Well, no, it's not quite as flat as I expected it to be. So still a bit of a party hat look. Questions on this? Let's do one more time for good measure. Let's do one more time for good measure. Make a little bit of a bigger circle this time. I just did. I'm supposed to do a little circle last time.
Oh, I just did a little circle this time.
Little circle this time. There you go. And well, actually, if I want to do ice cream on the board, I've got to make it a smaller circle, don't I? Well, oh well, forget ice cream. We didn't win anyway. Third place doesn't win anything, I found out. Rough life, isn't it, juniors? I know. No, blind, I couldn't read. Said right on a little paper, first and second place win the ice cream party.
Should have said first place in high school.
I know, that's what they've done every other year. Anyway, all right.
They're too lazy.
All right, and let's pick a point. Genesis, give me a clock position. 11. All right, so notice a little bit, and go a little bit outside the circle again. A little bit outside the circle. Again, first step class. Draw the line to the center. Number 2.
And this one.
Find the what?
Midpoint.
Midpoint. Perpendicular bisector. By the way, you can see the beginnings of a concentric circle here, right? Since you're measuring from the center, a little bit of a concentric circle starting to form. Drawing the midpoint, we divide that line in half, measure off that half. And there we go. All right. Any questions on this construction? All right, we'll look at these again tomorrow. We are looking at another construction quiz coming up Friday. We've got a couple more constructions we want to look at tomorrow as well. No homework this evening. Have a wonderful rest of your day.